Okay, welcome back. This is lesson 35. We are talking about similar and congruent polygons. Okay, and polygons are just shapes that are closed, so like triangles, rectangles, pentagons, all that kind of stuff. They have sides and they are closed. A circle is not a polygon because it doesn't have sides. Okay, so again, that's what a polygon means. Similar polygons have the same exact shape. Okay, so when I look at these three triangles, or these four triangles, sorry, I'm looking at the same exact shape. So this one and this one, you'll see, are the same exact shape. One's bigger than the other, but that doesn't matter, okay? This one is also the same exact shape, it's just turned compared to the other ones. So, these three are similar. However, this one over here is not similar because it is not the same shape as all the other ones, okay? It is slightly different. It is a right triangle, whereas the others are not. So, this one is not similar with the other three. Okay? So that's how we identify similar. Now, I'm going to have to erase this. Alright, so the other thing that we need to make sure we know is, okay, so the next thing we need to talk about is corresponding parts. Okay, corresponding parts are parts that are in the same spot on different shapes. Okay, but again, they have to come from similar shapes. So, for example, let's say I named this triangle A, B, B, C, and this one is D, E, F. Okay, well, again, they're in the same spot, but on different shapes. So, if I look at, let's say, angle A, okay, angle A is corresponding to angle D because they're in the same spot on the different shapes. Okay, so angle A is corresponding to angle D. Likewise, angle B would be corresponding to angle E. Okay, and angle C would be corresponding to angle F. Okay, now sides. Side AB would be corresponding to side DE because they're in the same spot on the different shapes. Side BC would be corresponding to side EF. And side AC would be corresponding to side DF. Okay? So now we could also, let's say we name this G, H, and I. Okay, now you can tell that this triangle over here is turned. So in this case, angle G would correspond to angle D, and angle H would correspond to angle E. And then this one, which is supposed to say I, would correspond with F. Okay, but that's what corresponding sides are. If they're like facing the same way, they're in the same spot, okay, on the different triangles or on the different shapes. Okay, let's go on to the next slide. Okay, and congruent polygons have the exact same shape and the exact same size. So for example, these are all trapezoids. Okay, and it doesn't matter what way they're rotated as long as they are the same size. So again, you can tell that this one and this one are the same size for sure, and if we turn this one, it appears that it would also be the same size to make them all facing the same way. Okay, so again, congruent polygons, same size, same exact shape. And the way we say that, okay, let's say that we called this one, oh, I don't know, let's go A, B, C, D. And let's say we made this one E, F, G, H. Okay, we would say that A, B, C, D is congruent to, that's the sign for congruent, okay, E, F, G, H. Okay? So those are congruent to each other. A, B, C, D is congruent to E, F, G, H. And again, this sign right here means is congruent to. Alright, let's go on to the next slide. Alright, objective 1 is to determine whether figures are similar. And again, this right up here says two polygons are similar if the corresponding angles are congruent and the corresponding sides are proportional. Okay? So when I look at A and B, alright, the corresponding angles, well, 100 and 100, those are equal. 80 and 80 are equal. 80 and 80 are equal. And 100 and 100 are equal. So the top left are equal, the top right are equal, the bottom left and the bottom right are equal. So it follows the first step. The corresponding angles are congruent. Okay? Then we have to know, are the sides proportional? So, to figure out if the sides are proportional, we need to set them as proportions. Okay? So I need to know, does 12 over 8, okay, and we get that from these two sides, 12 over 8, does that equal the other two sides that are supposed to be proportional, 8 over 6. So notice we took the top side and the left side and put them in a fraction. So then I need to take the top side and the left side and put it in a fraction. Okay, does 12 over 8 equal 8 over 6? Well, we can find that out by doing cross products. 12 times 6 is 72. Okay, and 8 times 8 is what? It's 64. Okay, so those are not similar to each other. Okay, they are not similar. Alright, so then we can factor in C here. Now the only problem that we have with C is it's turned compared to the rest of them. So if I redrew C, and actually on this last one, I'm sorry, I should write this is A compared to B. Okay. So now if I redrew this one, then the top number would be 6 and the side would be 4. Okay, and that also means that the top left angle, if I rotated it, would be right here. So this one's 100, which means this one's 80, because we get that from here. Again, we rotated it. So then the bottom one has to be 80, and this one has to be 100. Okay? So we can see that the angles match up with the other two. Alright, we got the 180 and 80, 100 pattern again. So now we need to tell. Let's compare A to C. Okay, so again, we're going to do 12 over 8 equals 6 over 4. Again, we got that from the top side over the left side equals the top side over the left side after we've rotated it so that it faces the same way as the other ones. Now again, try cross products. 12 times 4 is 48, and 8 times 6 is 48. So there we go. Those two things are equal. That means that A is similar to C. Okay, and this little squiggly is a line for similar. And since A and B were not similar, then B and C cannot be similar either. Okay, and that's because A and B, or sorry, A and C go together. Since these two go together and these two don't, these two cannot. Okay, now what about D? Well, if you look at D, if we try to match up the angles, 100 and 100, then 80 and 100 are in the same spot. So those cannot be similar. Okay, so A and C are the only two similar ones. And again, we found that by using cross products. Okay, solving a proportion. All right, let's go ahead and go to the next slide. Okay, objective 2 is to find the missing side of similar shapes. Okay, so the steps are right over here. All right, make sure you get those written down. Example 2 says the triangles are similar. Find x. Well, if they're similar, that means I know that this side has to go with this side has to match up with this side, and this side has to match up with this side, and they all have to be proportional. Okay, so the very first thing that I want to do is find the side I'm trying to solve for. So that's right here. Okay, and I'm going to put that on top of my proportion. Okay, so I picked the right side of my triangle. Then, okay, I can pick either one of the other two numbers. It doesn't matter, since I know all the numbers over here. Okay, the only thing that I want to make sure of is that if I pick 12, it's got a number that matches up with it on the other triangle. Well, 12 matches up with 4, so that's good. Okay, I could pick 15 because it matches up with 5. It does not matter. Okay, so let's go ahead and pick 12. So I picked the bottom side. Okay, so the right side over the bottom side. So the right side over the bottom side has to equal. Then we're going to go the other shape and do the right side. I'm sorry, I should put labels. Over the bottom side, which is 4 inches. Now if I set up my proportion correctly, look at this. X and 3 match up just like they matched up in the triangles. and 12 and 4 match up just like they matched up in the triangles. Also, x and 12 came from the same shape, so they go together. And 3 and 4 came from the same shape, so they go together. Now I solve the proportions by using cross products. Okay, so I'm going to write 4 times x equals 3 times 12 is 36. And then I want to know 4 times what equals 36? Well, I can solve that by taking 36 divided by 4, and that's 9. So x equals 9. Then I need to answer my question. Okay, x equals 9, and I should have a label, inches. Okay, let's do one last example. Okay, example 3 says an architect makes a scale drawing of a building. Then it says if 1 inch on the drawing represents 4 feet, okay, so I'm going to write that down, 1 inch equals 4 feet, then what is the scale factor from the drawing to the actual building? So this is the drawing to the actual building. Okay, well, a scale factor means I want to know how many times bigger is the actual building than the drawing. Well, you're going to look at the numbers, okay, first, and notice that they're 4 times bigger. However, the labels are different, which means we have to come up with the same labels. Okay? So I need to figure out, since I can't really convert an inch into feet very easily, I'm going to leave that. And I want to know 4 feet is how many inches? Well, I know there's 12 inches in 1 foot, so 4 times 12 is 48 inches. Okay? So my scale factor then is 48 from the drawing to the actual building, because I take 1 times 48 to get to the actual size. Okay? So the scale factor is 48. So the actual building is 48 times bigger than the drawing. Okay, so what that means is in part B, if I have the length and the width of a room, that's 5 inches by 4 inches, I want to know how's that compare to the actual building. Alright, well, I know that I'm going to have to take 5 inches times 48. And I'm going to have to take 4 times 48. Okay? Well, 4 times 48 is 32. Carry the 3. 4 times 4 is 16. That's 192 inches. Okay? And then 5 times 48, I'll do that up here, is 40. Carry the 4. That's 240 inches. Okay, so I could say that the length is 240 inches and the width is 192 inches, but it would make a lot more sense in real life to make it in feet. Okay, so now I'm going to take 192 inches and divide it by 12. Okay, and I'm also going to take 240 inches and divide it by 12. Okay, well, 12 goes into 19 once, and I subtract and get 70, bring down the, or 7, bring down the 2, and it goes in there 6 times. So that means it's 16 feet wide, and then 12 goes into 24 twice, and 12 goes into 0 0 times. So 20 feet long. Okay, so there's your video. If you have any questions, go ahead and ask. Otherwise, happy homeworking.